Today we are working on notes 3.4, factoring and graphing polynomial functions. So the first step to factoring is to figure out what method you should try. We do that by figuring out the number of terms in the polynomial. So if it has two terms, GCF, difference of perfect squares, sum or difference of cubes, three terms, GCF, trinomial factoring. So first one, example one, we want to factor it, right? So I see that it's two terms, 1, 2. So I'm thinking GCF because it's not a difference, maybe a potential cube, depending on what we factor out, but we'll see. So I see, right, my GCF definitely can take out a -3 and an x squared, right? Because -3 goes into -3 and 12. It's x to the fourth and x squared, so I can take out an x squared. So if you factor out a -3 x squared, what would be left, right? Well, there would be no -3, and this would just be x squared. This would be a minus now, because you factor out a negative. And 3 goes into 12 4 times. Okay. So now, how many terms? 2 terms. No GCF, because we got that out of the way. But that is a difference, and they're both perfect squares. So it's a difference of perfect squares. Remember, that's two binomials. They're exactly the same other than the signs. The only difference is one's plus, one's minus. Doesn't matter which one you say plus or minus. So what do you square to get 4? 2 and 2. So this would be completely factored. Okay, next one. Again, 1, 2 terms, right? It's got 2 terms. So I'm thinking GCF. Right? This last one had 2 terms. So I tried a GCF. So I notice they both share an x, so I can factor out an x. That would give me x squared minus 36. Again, 2 terms. That's a difference of perfect squares again. So 2 binomials. The only difference is one's plus, one's minus. So this would be x, x. What do you square to get 36? 6 and 6. Okay. Next example, again, 2 terms. Right, so I'm thinking GCF possibly. Maybe a difference of squares, we'll see. So I can factor out a 4 and an x squared. So this will give you x squared minus 9. Again, difference of squares. So 2 binomials. The only difference is one's plus, one's minus. X, x, 3, and 3. So you're going to see difference of squares decent amount of times, so be aware of that. GCF's quite a few times. Okay. Oh, this one's a little different. 3 terms. So is there a GCF? Well, technically there is one, but that's not going to really help us too much, okay? So then it's got to be 3 terms. There's no GCF. It's nothing we've really seen. So our only option that we have is trinomial factoring. So remember, if it's 3 terms and factors, it's going to be 2 binomials. It's really all we've had because there's no GCF. Okay. So how do you get x to the fourth? Well, that would be x squared, x squared. Okay. Now, what are the multiples of 36 that will add to give you 13? Well, let's see. 1 and 36, 2 and 18, right? 3 and 12, 4 and 4 and 9. 4 and 9 will make 36 when you multiply, and they can make 13. So 4, 9. It's got to be a minus 13, so both of these have to be minuses. So this was actually very similar to our basic trinomial factoring that you did a lot in Math 2, The only difference was I changed the power to a 4 and a 2, but it's the same concept, right? It's a trinomial with GCF of only 1, so the only tool we have is to break it into 2 binomials. That's it. That's all we have. Notice both of these are difference of squares, so we can go one step further with both of them. So x plus minus, so what do you square to get 4? So 2 and 2. X plus minus, what do you square to get 9? 3 and 3. So this would be your fully factored form. This one is one that's very tricky for a lot of students because you've never seen that before, but you've used the concept before. So that one is a tricky one for students. So now if you go to the next one, well, you're like, oh great, now 3 terms. Yeah, it's 3 terms, but I notice I see a GCF in there. I see some common variables, right? I see some constants that are common. So yes, this does have 3 terms, just like the last one had 3 terms. But I do see a GCF, right? I see that they all share at least an x squared, and they're all divisible by -5. So that's going to help. So if I factor out -5x squared from the first term, you'd have x squared. This would become a plus x. Okay, and then 5 goes into 100. Right, so this would be -20. There we go. Okay, so there's a trinomial. Looks a little nicer than the last one we just did. So if it's going to factor, it's going to be 2 binomials because it doesn't have a GCF other than the 1 because we already took the 1 GCF out. So x squared is from x and x. So what are the multiples of 20 that give you 1? 1 and 20, 2 and 10, 4 and 5. Oh, there we go. So 4 and 5. That'll give us 1. It's got to be a positive 1, but the minus sign means they're different. So that means this is going to be positive, this is going to be minus. So there you go. Fully factored. Okay, and the last one, again, 3 terms. Oh, so it is a trinomial, so I'm still thinking GCF. So I notice they all are divisible by 2, and they all share at least an x. So this would be x squared. 2 to the 16 is 8. Take an x away. 2x, 32x, so this would be plus 16. Okay, so again, trinomial that we can factor, hopefully. So it'd be 2 binomials, so multiples of 16 that add up to 8. So 1, 16, 2 and 8. Oh, 4 and 4, that will work. So 4 and 4. Minus sign, right, and plus. Plus, that plus right there means that they're going to both be the same. They have to add together to give you -8, so they're both minus minus. And there you go. Fully factored. So why did we review factoring? Well, if you remember back at the beginning of the notes, I told you one of the hardest things in this unit is going to be finding the x-intercepts. Well, so far up to this lesson, most of our equations have already been in factored form. Right? So now they're going to start being in what we call standard form. So it should be easy to figure out the degree and then behavior and the y-intercept. But now it's going to become a little more challenging to find the x-intercepts because you're going to have to do a step or two before you can get into factored form. So we're going to have to factor this and then sketch our graph. Okay. So we have y equals 4x to the 4th minus 16x squared. So 2 terms, GCF, right? So I can factor out an x squared and a 4. Right, so this will give you x squared minus 4. Okay, so 4x squared, that's a difference of perfect squares. So plus 2 minus 2. So we started off in standard form. Now we're in factored form. So we had to use factoring to get it into factored form. So that's one tool that we have. So now to find the zeros, we set our equation equal to 0. Right, to find the x-intercepts, y has got to be 0. Right? So 4x squared equals 0, x plus 2 equals 0, x minus 2 equals 0. So x equals negative 2, x equals 2. Divide by 4, x squared equals 0, so x equals 0. So these are our 3 x-intercepts. 0, negative 2, and 2. So I have my 3 x-intercepts. Now I need my y-intercept. Good news is we already have the y-intercept. It's right there at 0. That's what's nice about having an x-intercept of 0. It's also a y-intercept. So I have my x-intercept, I have my y-intercept. So now I need the end behavior. Well, it's 4x to the 4th. So that means it's even and positive, so it's high to high. So now I have everything I need. X-intercepts labeled, done. Y-intercept, done. End behavior, done. So now I can sketch the graph. So it starts high, comes to negative 2. What happens at negative 2? The factor only occurs once, so it passes through it. Perfect. Now I got to get back up to 0. Okay. So now what happens at 0? Well, it's x squared. So it bounces off 0, comes back down, and now I got to get back up to 2. What happens at 2? It passes through because it only occurs one time, and I end high. Perfect. How many max or mins do I have? Well, I have 1 max, right, at 0, and 2 mins. Right? Minimum, minimum, maximum. So 1 max, 2 minimums. So how is this different than the previous lessons? Well, it was in standard form. We had to factor it to find the x-intercepts. That's how it's different. Okay, example 3, flip it over. So now we got some weird notation, so we got to get it into something we recognize first. And then we're going to do a very similar process. Factor it, get into factored form, x-intercept, y-intercept, and behavior, sketch the graph. So what does this stuff mean? Well, this is times. So it's f times g. So your equation, y, is going to be negative 5x times x to the third plus 3x squared minus 10x. That's what the dot means. Times. So I did that. Now, some students have the tendency to literally multiply the negative 5x through the whole trinomial. Don't do that. You're trying to factor it. You're trying to break it down. So if you multiply the negative 5x through, it's going to make it way more complicated because you're trying to break it down into its factors. You want it into smaller pieces. So now all I'm going to do is factor this. So y equals the negative 5x is fine. So it's 3 terms. I see a GCF, right? I can take out an x. So this would be x squared plus 3x minus 10. That's a trinomial I can factor, right? We can combine this. So negative 5x squared. This would be 2 binomials. Remember, trinomials factor into 2 binomials if you can factor them. So x and x. So what are the multiples of 10 that'll add to give you 3? Or you can subtract to get 3, however you want to look at it. So that would be 5 and 2. Plus 5 minus 2 because it's a positive 3. So now I'm fully factored. So I'm going to let y equals 0. Right? Y equals 0. Right? I went from standard form down to factored form. So negative 5x squared equals 0. X plus 5 equals 0. X minus 2 equals 0. So x equals 0. 1. Negative 5. 2. Positive 2. 3. So those are my 3 x-intercepts. 0, 0. Negative 5. And 2. Okay, perfect. So I got my x-intercepts. Second, y-intercept. Oh, yay. Winner there, right? X equals 0. That's a y-intercept and an x-intercept. So I have both of them. So now I just need my end behavior. So I'm going to go back and I'm going to look right here where that black arrow is. Oh, sorry, not there. That's still too far. I'm going to look back here where that black arrow is. All right, we have the factored form here that I'm circling in black. You can figure it out there, but the end behavior is a lot easier to figure out when it's in standard form. So the blue part where the black arrow is fairly close to standard form. So it's x to the third times a negative 5x. So it'd be negative 5x to the fourth. So that means it's odd. Oh, sorry, not odd. It's even and negative. So then behavior would be low to low. So I have everything I need. X-intercepts, y-intercept, and behavior. So I start here at low, I go to the negative 5. Okay, so at negative 5, it either bounces off or it passes through. Well, the factor for that 0 is x plus 5. It occurs one time. So I'm going to go through it. Okay, got to get to 0, so curve back to 0. Okay, now at 0, it's x squared. That a factor occurs twice, so it's going to bounce at 0, and then bounce right over here to 2, because it's got to go through 2. I don't get to cross anywhere other than negative 5, 0, and 2. Those are my only 3 points that I can potentially touch or cross the x-axis. And at 2, that factor only occurs once, so it goes through the 2. And how many maxes do I have? 1, 2 max. And I have 1 min at 0. Okay. Okay, example 7. Or sorry, not 7, 4. Yeah, first 4. Okay, so same idea. We start off with some weird notation. So f minus g means you're going to take 3x to the 5th and you're going to subtract g of x. This is where you got to be careful because this is where some students get into trouble. The minus, right, you're subtracting. So you have to distribute that minus through. So this is 3x to the 5th minus 18x squared plus 24x. Okay, so that's a tricky one. You got to remember that minus, you have to distribute that through. Okay, so now we're in standard form. This here is standard form. So we're going to have to eventually factor it, but we might as well get the end behavior right now. So it's x to the 5th. So that means it's going to be odd. And it's a 3, so it's positive. So then behavior is low to high. So again, in standard form, it's easier to figure out the end behavior. So I would just figure it out first. So now, let's find the x-intercept. So we're going to have to factor it. So I do see a GCF of x. So this would give us 3x to the 4. Oh, and it's divisible by 3. Oops, almost missed that. So 3x. So x to the 4th minus Oh, that's a 3. Oh, no wonder. I'm like, it's 3. Whew-wee. I'm like, that's going to make this math real interesting. It's a 3. Whoops. So x to the third. Okay, so we can still take out a 3x, but this would be x squared minus 6x plus 8. I was going to say, our math was going to get real interesting right there with an x to the fourth and x. Okay, so it was x cubed. I do apologize about that. So I factored out a 3 and an x because 3, 18, and 24 are all divisible by 3. And at least one x is in every single term. So now I do have a trinomial that looks like it'll factor. If it does, it'll be two binomials, so x and x. So what are the multiples of 8 that will give you 6? 4 and 2. Plus sign means they're the same, so minus minus, because it's got to be negative 6. So now this part here in green that I'm circling, that is factored form. So the part up here that's underlined in black, that was standard form. Now in green is a factored form. So I'm going to let y equal 0, and I'm going to find my x-intercepts. Okay, so we're going to have x is going to equal 0, x is going to equal 4, x is going to equal 2. So those are my 3 x-intercepts. I set each factor equal to 0, and I'll get 0, 4, and 2. So 0, 4, and 2. Okay, good news is the y-intercept is already found because we have 0 as the x-intercept. So remember, if x is 0, y is also 0. Right? If you have the origin, it's an x-intercept and a y-intercept. It's both. And I have the end behavior, so I have everything I need. So I start low, I go to 0. What happens at 0? It's going to pass through because it's only x to the first power. Okay, then it's got to come back through 4, pass through 4 because it only occurs one time, and then back up through 2. And sometimes you might have to relabel, so 4 and 2, because you need to make sure you label your x-intercepts and your y-intercept. Okay, and then the last example, second number 4. So again, it's a minus, right? So it's y is going to equal negative x to the fourth minus 4x cubed plus 4x squared. So I'm going to make sure I distribute the negative. Okay. So might as well figure out the end behavior because the part I'm underlining in black is standard form. So it's the fourth degree. So it's even. Negative x to the fourth. So it would be low to low. So now I just need x and y intercepts. So now I got to factor it. I do notice it has a GCF, right, of x squared. Technically, you could do a negative x squared. So what would be left? This would be x squared plus 4x plus 4. This is a trinomial that looks like it can be factored. If it does factor, it would factor into two binomials. So we have x, we have x. Multiples of 4 that add to 4. Well, that's 2 and 2, so plus, plus. So there we go. So now this part in pink or purple, whatever it looks like on your screen, is factored form. So I went from the part that's underlined in black, factored it with a GCF and then trinomial to get the part in pink there. So now that's fully factored. So now I'm going to set it equal to 0. And figure out my x-intercepts. So when you do that, you're going to end up getting x equals 0, x equals -2, x equals -2. Notice this occurs twice. You don't get to draw it on there 2 times. That means it's going to bounce. And it's going to bounce at 0 as well because it's x squared. So this occurs 2 times. So it bounces at -2 and it bounces at 0. Good news is we also have the y-intercept because we have an x-intercept at the origin. So we're good. We have the end behavior up top in black. The x-intercept's here in blue. And the y-intercept is the same as the x-intercept at the origin. So I have everything I need. So I am going to start low, bounce off, come up, bounce off, and there we go. How many distinct x-intercepts? There are 2. Oh, back up here, I missed that part. How many distinct x-intercepts up here? There are 3. So again, the whole idea behind this lesson is being able to factor to get it from standard form to factored form so you can find the x-intercepts. Really, everything else we're learning for the rest of the unit is different ways to find the x-intercepts, depending on the equation. Please make sure you answer your essential question as you write your summary, and then you'll be done with your notes.